A magnet shouldn't stick to stainless steel. Is that really true? And if the magnet sticks to stainless steel, does that mean it's fake? Hey, detailed engineering, have you heard people claim that good stainless steel isn't magnetic? Or even tests done here on the internet trying to show that if a magnet sticks to stainless steel, then it's fake. Well, not all stainless steel is the same, and the interaction with magnets depends on the microstructure of the material, not its quality or whether it's real or fake. There are families of stainless steels that are naturally magnetic and others that, under typical conditions, are not. So, why does this happen and what really defines if stainless steel is good? But let's get to it. Why are some metals attracted to magnets and others not? This has to do with the arrangement of the atoms and how the magnetic moments align, practically speaking, for stainless steel. If the microstructure is austenitic, with a face-centered cubic crystal structure, the material is typically non-magnetic or only weakly paramagnetic. Now, if it is ferritic, or body-centered cubic, or martensitic, which is a tetragonal form derived from iron, it is ferromagnetic and will attract a magnet. In other words, the phenomenon is related to the steel phases present after manufacturing and treatment. And what are the stainless steel families, and how does this affect the magnet? The stainless steels? Austenitic, like those from the 300 series, for example. The ASI 304, in annealed conditions, normally does not attract magnets, unlike ferritic ones like ASI 430, and martensitic ones like ASI 410 and ASI 420. They are magnetic. Duplex steels like SAF 2205, which combine austenite and ferrite, tend to be partially magnetic. Therefore, the behavior in relation to a magnet is a reflection of the microstructure, where austenite in general is not magnetic. Ferritic and martensitic steels are magnetic, and when you have a mixture, it has intermediate magnetism. But I've heard that nickel is the secret to stainless steel that doesn't stick to a magnet. Is that true? In part, yes. Nickel is an austenite stabilizer in AC304, for example. The typical composition is around 18% chromium and 8% nickel, which favors the non-magnetic austenitic phase. In IZ316, in addition to chromium and nickel, there is molybdenum, typically 2% to 3% to improve pitting corrosion resistance in chloride environments. ASI 430, a common ferritic stainless steel, has about 16% to 18% chromium and little or no nickel, making it naturally magnetic. ASI 410 martensitic has around 11.5 to 13.5% chromium and a carbon content that allows hardening, also exhibiting magnetism. But why does an ASI 304 sometimes attract a magnet only on the bent edges or deformed areas? The answer lies in martensite, which is induced by deformation when 304 undergoes cold working, such as bending, drawing, or stamping. Part of the austenite can transform into martensite, which is ferromagnetic. The practical result is a 304 that remains barely magnetic in the areas that weren't worked and shows noticeable attraction where it was deformed. This doesn't mean that the material is fake or of low quality. It's a well-known metallurgical effect in austenitic steels, with certain combinations of chromium and nickel. Did you notice how even a simple magnet test actually hides super complex materials engineering behind it? Uncovering the truth behind myths and deeply understanding every technical detail is what sets a good engineer apart. In weld beads of austenitic steels, it's common to have a fraction of delta ferrite in the weld metal to reduce susceptibility to solidification cracking. This ferrite is ferromagnetic, so a magnet can stick to the weld bead area or the heat-affected zone, even if the main body of the material is mostly austenitic and non-magnetic. Again, this doesn't indicate counterfeiting, it just shows the presence of a magnetic phase locally due to the welding design. But hold on, does a magnetic stainless steel mean it's worse against corrosion and non-magnetic means it's better? Not necessarily. Corrosion resistance depends on the composition and the environment, not on magnetism. There is ferritic stainless steel in refrigerators and panels, which works very well in indoor and dry environments, even though it's magnetic. In marine environments or those with chlorine, AIC316 is usually preferred because of the presence of molybdenum. On the other hand, 430, although useful and economical for indoor applications, has lower resistance to pitting corrosion in chloride environments. So, does it stick or not? A magnet does not determine corrosion resistance performance, and there is fake stainless steel. Unfortunately, there are cases of poorly specified or incorrectly labeled materials, but using a magnet to detect counterfeiting is a misleading shortcut. The difference between material that is unsuitable for the application and counterfeit material is significant, and the magnet does not distinguish this. And how can you really check what the alloy is? For reliable grade identification, PMI methods or positive material identification are used, such as X-ray fluorescence spectrometry or optical emission spectrometry, which measure the chemical composition and confirm the levels of elements like chromium, nickel, and molybdenum. Material certificates from the supplier, with traceability and the applicable standard, are also essential. Specific corrosion tests or criteria such as PREN help compare performance in chloride environments. None of this is replaced by a magnet, and you can use a magnet for some quick screening in daily routines. Well, yes, but only as a screening tool and with caution. If a component is strongly magnetic, you might suspect it's ferritic or martensitic. If it's practically non-magnetic, it could be annealed austenitic, and if it's somewhere in between, it's likely deformed austenitic. But this is just a preliminary indication and isn't suitable for testing quality, authenticity, or suitability for the application. For responsible design, purchasing, and specification, ask for the grade, check standards, and use suppliers with technical documentation and a reliable track record. So, what's the final message? For those who associate good stainless steel with not being attracted to a magnet, the message is: magnetism is not a quality criterion for stainless steel, it just reveals something about it. At most, it shows which metallurgical phase is present, and this varies with the alloy family, processing, and composition. What defines if a stainless steel is good is whether it is suitable for the environment and its function. And the magnet doesn't tell the whole story if you saw a video using the magnet test as a verdict of authenticity. It is worth asking what family the stainless steel belongs to, what the manufacturing process was, and what the environment of use is. These three answers explain pretty much every case where a magnet sticks to stainless steel, and at the same time debunk the idea that if it sticks, then it's fake. In engineering, context is everything, and when it comes to stainless steel, context means microstructure, composition, and environment. If you've made it this far and enjoyed the video, go ahead and subscribe if you haven't already, leave a like, and turn on the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and to be mentioned in our videos. To learn more about our recommended courses, scan the QR code or use the link in the video description to get access to our list of recommended courses for you to improve your technical skills and develop new abilities. So, had you ever seen this magnet test with stainless steel? Were you someone who believed that stainless steel couldn't attract a magnet? Let me know in the comments. I want to hear from you. Right here on the side, there are two interesting video options that you need to watch to expand your knowledge and explore your curiosity. And if you want to support us, leave a like, subscribe to the channel, turn on the notification bell, and consider becoming a channel member. That's it, engineering enthusiasts. Take care, and I'll see you in the next video.